Welcome. This is the second video of MCQ for linear differential equation topic. I also have uploaded MCQ videos for matrices and discrete maths related videos as well. So let's start. If I have to solve this problem, actually this problem is related to finding particular integral, right? When you solve a non-homogeneous linear differential equation, you have to find the particular integral. So here they are just asking you to find the particular integral. What is the formula that we are going to use? So first understand that 1 by fd e to the power ax is equal to 1 by fa e to the power ax, provided fa is not equal to 0. If it will be equal to 0, then what we have to do? We will discuss through different problem. So here 3 is a constant. So 3 will be out of the operator and I will operate d square minus 2d minus 3 on e to the power 2x. Now 3, I have to replace d by 2. So I will get 2 square minus 2 into 2 minus 3 e to the power 2x. Now 2 square is 4, 2 into 2 is 4, so cancel. 3 and 3 is cancel, so we are getting minus e to the power 2x. So what is the answer? The answer is B. Easy question. Now let us look at this problem. So in this problem, if you simply replace d by a the way we have done in the previous problem, there will be a challenge. What will be the challenge? 2 into, here a value is, what is the coefficient of x? 1 by 2. So if you put replace d by a, this will be 2 into 1 by 2 minus 1 square. So basically it will be 0. So this result is valid only when fa is not equal to 0. So now the question is how to solve this problem. So there are different ways of solving this problem. I am going to talk about a general way which will help you in all this kind of situation. So the idea is that 2d minus 1 square e to the power x by 2. So whenever we get 0 here by the direct substitution, what we do, first we multiply it by x in the beginning, right? We multiply it here by x and we differentiate this thing, the denominator, with respect to differentiate denominator fd rather with respect to capital D. So if I differentiate this with respect to capital D, d by dd of 2d minus 1 square. So that is equal to 2d minus 1, and by chain rule again this will give me 2. So here I will get 4 2d minus 1 e to the power x by 2. Now I will check it whether it is 0 or non-zero, but the problem here is that in case if you replace d again by 1 by 2, you will get 2 into 1 by 2. So it will become 1, 1 minus 1 will become 0. So I will repeat this process again. I will multiply x again. So x into x, and I will differentiate this thing again with respect to d. So 4 is a constant. Derivative of 2d minus 1 will give me 2 e to the power x by 2. Now we don't have any d term, so our problem is already solved. So x square by 8 e to the power x by 2. So which option will be correct? C option will be correct. This is an important question. You should be clear about the process because sometimes the direct substitution may result into 0, and in that case this will work. Okay. So the next problem is finding the particular integral 1 by d square plus 4, and that we are operating on 6 of cos x. I hope you know the formula. The formula that we are going to use is 1 by fd square of cos ax is equal to 1 by f of minus a square cos ax, and this will be applied only when f of minus a square is not equal to 0. First of all, be clear about the process here. The idea is that 6 is constant, so I am taking 6 out of the operator and I get here d square plus 4, and that I need to operate on cos x. So if I ask you what is a here, so a here is 1 because the coefficient of x is 1. What is a square? A square is 1. What is minus a square? That is equal to minus 1. Some student confuse it with minus a square. No, it is not that. It is a square with a minus sign, right? So what is the value of a square with a minus sign? That is equal to minus 1. So the formula tells me that you replace the d square by minus a square, that is minus 1 in this case. So it will be minus 1 plus 4 cos x. So what will happen? I will get 6 into 1 by 3 cos x. So 6 and 3 cancel, so I will get 2. So the answer will be 2 cos x. So which option is correct? The option A is correct. Okay. Let us see another interesting question. Here also we have to use the formula 1 by f d square of sine ax. So in case of sine also we apply the same idea, that we replace d square by minus a square sine ax. So here the fd is this thing, d to the power 32 plus d minus 1, and then sine x. Okay, and the idea is that d to the power 32 can be seen as d square to the power 16 plus d minus 1 of sine x. You might be thinking, what is the need to do that? Because we are looking for the term d square. So d square is replaced by what is a here? A here is 1. What is a square? A square is also 1. What is minus a square? That is equal to minus 1. So basically I am going to replace this d square by minus 1, because minus a square is minus 1, and to the power 16 plus d minus 1 of sine x. Now minus 1 to the power 16 is basically 1 and minus 1. So this 1 and minus 1 is cancelled. What I get? I get 1 by d of sine x. And you know what is the meaning of 1 by d? d stands for the derivative, that is d by dx. So 1 by d is the inverse operator of differentiation, means it is integration. So 1 by d basically stands for integration. So what is the integration of sine x? The integration of sine x is minus cos x. So what is the answer? The answer is D. I hope you are getting it. So in this video, we are basically taking different kind of problem. We have taken sine related, exponential related. Now here we have a polynomial related problem. So suppose I have to solve 1 by d square plus 16, because fd here is d square plus 16 of 64x square. So you know, when you have the polynomial, what you do, you use the binomial expansion. So I will explain. Let me first take the 64 term out, and here we have d square plus 16 of x square. You know, gentlemen, what you need to do, you have to write the denominator here as 1 plus or minus something, right? 1 plus or minus something. That may be a function of d, 1 plus minus some function of d. So, and the d should not come in the denominator, means basically what we are going to do, first let me write and then I will explain. 64, I can take 16 common, so I will get 1 plus d square by 16. So that is my aim here, that I want to get 1 and then I want to get some function of d. And since it is d square, so if I write it d square by 16, I will get d square, right? So 16 and 16 will be cancelled, and basically I will get this term. Some students make the mistake. What they do, they take d square common and then they write 1 plus 16 by d square, which is not correct, because we don't want this d square term in the denominator here, right? This d square should always be in the numerator of this function. I'm talking about the function which is appearing in the denominator. So this function, right, x square. Now the 16 and 64 is cancelled, so I will get 4, and here we are getting 4, and 1 by 1 plus d square by 16 can be written as 1 plus d square by 16 to the power minus 1 of x square. And there is a popular result, I hope by now you are clear about. I am writing for your convenience. The result is that 1 plus x to the power minus 1 is 1 minus x plus x square minus x cube and up to infinity. And we have a similar result. I am writing for your reference that 1 minus x to the power minus 1 is 1 plus x square plus x cube and so on. So did you notice the difference? When you have plus, the sign are changing alternatively, plus and then minus. And it is minus, then every term is positive. So what will I get here? I will get 4. It is plus, so I will write 1 minus d square by 16. Next term will be a square of this, d square by 16 square. So basically I will get d to the power 4 by 16 square. But this is not needed. Actually, this term is not needed. I have written for you for your understanding, because we have a polynomial x square here. And if I differentiate x square more than twice, I will get 0, because in first derivative it will give you 2x. In second derivative it will give you 2, and third derivative will become 0. So this d to the power 4 term is not needed. So basically what will be the answer? 4. 1 into x square is x square, and minus 1 by 16 is the constant, and d square of x square is what? Means you have to differentiate x square 2 times. So first derivative will give you 2x, second derivative will give you 2. So I will be getting 2 here, right? So basically what is the answer? 4x square. Let me write it here because we don't have a space. The answer is 4 into x square. So I am writing here 4x square minus 4 into 2 by 16. So this term and this term cancel, 2 and 4 cancel, 1 by 2. So we are getting 4x square minus 1 by 2. So the correct option is A. This was an interesting question. I hope you understood it. Now this is a question related to solving the differential equation by method of undetermined coefficient. And what is the process here? Because method of undetermined coefficient requires you to choose a trial solution, right? So that trial solution gives you the particular integral. So the differential equation is y double dash plus y is equal to 32x cube. So to choose the trial solution, what we do, we look at the right hand side of the differential equation. And when we look at this, this is a polynomial of degree 3. So the trial solution or the particular integral that we have to select is a polynomial of degree 3, and that polynomial should be a general polynomial. You know what do I mean by general polynomial? By general polynomial I mean that it should contain x cube term, because it is a polynomial of degree 3, and it should contain all other terms of of degree less than 3. Means it should contain x squared term, it should contain x term, and it should contain constant term, right? So the trial solution should have x cube term, x squared term, x term, and constant term. So the correct answer will be what? The correct answer will be c1 plus c2 plus c3. Here it should be c3x plus c4. So the correct answer will be D. See, even though I have got the correct answer, I want to discuss something more about this problem. The point is that here I have the right hand side, that is 32x cube. So if suppose the right hand side in place of 32x cube is 32x cube plus 7. So this is also a polynomial of degree 3. So in that case also the trial solution will be this, because we are not looking at the what is there in the right hand side. What we are looking at, what is the degree of it. Suppose we have 32x cube plus 2x square plus 9x. If this polynomial is in the right hand side, again the trial solution will be the same, because we just have to look at what is the degree of this polynomial. So degree is 3, so the trial solution will be a general polynomial of degree 3. Okay, I hope you got it. So let us see another problem related to the method of undetermined coefficient, and here it will be slightly different, so be careful. So the differential equation given is y double dash plus 4y dash plus 4y is equal to 12e to the power minus 2x. So when the right hand side is an exponential function, in that case the trial solution or the particular integral is taken as a constant c1 e to the power minus 2x. Let me explain this and in a general way. What I am saying is that suppose the right hand side is e to the power mx, right? So what will be our trial solution? Our trial solution will be yp is equal to c1 e to the power mx. Here we have 12 e to the power minus 2x, so it is in the form of e to the power mx, so the trial solution will also be in the form of e to the power minus 2x. Some of the students may have the doubt that what about this 12? Are we not considering this 12? See, 12 is a constant and that constant will be adjusted with this constant. Are you getting my point or not? So writing a arbitrary constant here is taking care of this constant as well. So we just have to look at the function. The constant thing can't be ignored. But there is a catch here. What is the catch? This is not the answer. Why this is not the answer, or why this is not the trial solution? The reason being is that when we write the trial solution, we must also, and this is important, I am highlighting it, we must also look at the complementary function. So what is the complementary function for this non-homogeneous linear differential equation? If I ask you what is the auxiliary equation, so we will say it is m square plus 4m plus 4 is equal to 0. So the roots will be repeated roots, that is m is equal to minus 2 and minus 2. So the complementary function will be given by let me use another constant. Suppose I say constant a plus bx e to the power minus 2x. I hope you know that when the roots are repeated, we write the solution like this. Since I have used the constant c1 here, I am using another constant a and b here. So if you look at the complementary function, it has two terms. It has a e to the power minus 2x plus b x e to the power minus 2x. And if I take this as the trial solution, we realize that a similar term is also present in the complementary function. Only thing is that both of them are arbitrary constant, but the term is same, e to the power minus 2x, e to the power minus 2x. So what we do in that case, we need to multiply this by a power of x, so that this term that we are taking as the particular integral is not present in the complementary function. So suppose I multiply it by x. So when you multiply it by x, you realize that x e to the power minus 2x is also present. So we need to multiply it by another x, means higher power of x. So we multiply it by x square. So what is the answer now? The answer will be yp is equal to c1 x square e to the power minus 2x. And in that case, which option will be correct? The D option will be correct. This problem, if asked, lot of students will make mistake. They will select A as the option just by looking at the right hand side. Don't make that mistake, because you just don't only have to look at the right hand side, you also need to look at the complementary function. And if the term which you are considering as the trial solution is already present in the complementary function, in that case you need to multiply it by a suitable power of x. I am using the word suitable power of x. It means what? That if I multiply it by x and that term is also present, then we multiply it by x square and so on. Okay, let us move to the next question. This is also similar to one of the question we did earlier, but let me quickly solve this as well. So here it is 1 by 1 minus d square x to the power 4. So it is, everything is already in the nice form. In this kind of thing, we just write 1 by d square to the power minus 1 x to the power 4. And using the binomial expansion, I can write 1 plus d square plus d to the power 4 and so on. In the same video, in the previous question, I have explained in detail. So this time I am solving it quickly. So 1 into x to the power 4 is x to the power 4 d square of x to the power 4. So if you differentiate x to the power 4 once, you will get 4x cube. If you differentiate it again, you will get 4 into 3 12x square. So here you will get 12x square. And you have to differentiate d to the power 4 x to the power 4. So this was the first derivative, this is the second derivative, third derivative will be 24x, and fourth derivative will be 24. So this will be 24, and all other terms will be 0. So what is the correct answer? The correct answer is B. I hope you got it. So now let us solve this problem, and this is another kind of problem. This problem is related to the topic of Euler-Cauchy form of the linear differential equation. Euler-Cauchy form of the linear differential equation. Sometimes they just ask you to identify that the given differential equation is in Euler-Cauchy form. So you see here we have y double dash, so it is multiplied by x square term, a constant, and x square means a function of x square. Here y dash, it is multiplied by the first power of x. It means what? That second order derivative is multiplied by second power of x. First order derivative of y is multiplied by first power of x, and here we have the y term, so it is multiplied by a constant. So to solve this kind of problem, since it is the first such problem, I am going to explain it in detail. What you do, you make a substitution. So what is the substitution you make? You make the substitution z is equal to log x, or you can also say that you are making the substitution x is equal to e to the power z. And now you are using the notation capital D, which stands for d by dz. I am not going into the detail that why it happens, because then it will be like very time consuming. So the idea is that make a substitution z is equal to log x or x is equal to e to the power z, and then consider that the d now that I will be using will stands for d by dz. And what we do, we replace the term x y dash or x dy by dx, we replace this term by dy. Now again, gentlemen, I repeat, this d now stands for d by dz. If you have x square y double dash, you replace this term by d into d minus 1y. If you have x cube, which is not present here but just for the sake of explanation, if you have x cube y triple dash, then you replace it by d minus 1 and then d minus 2y. And similarly, one more term, let me write x4 y to the power 4, you replace it d minus 1, d minus 2, d minus 3y. Yes or no? So this is how you do the replacement. So in this case, if I replace this, what this differential equation will become? Let me call this differential equation 1. So 1 will change to, 1 will reduce to what? 2 x square y double dash will be replaced by d minus 1y, plus 3 x y dash will be replaced by dy minus 3y is equal to 0. So this will give me what? This will give me, you can see 2d into d, so 2d square minus 2d, and from here I will get plus 3d and minus 3y is equal to 0. So basically what we are getting? We are getting 2d square plus d minus 3y is equal to 0. Actually it is factorizable here, but I am writing it just to explain so that you don't miss the process. So the idea is that the Euler-Cauchy form of the differential equation will reduce to the linear differential equation with constant coefficient, and you know how to solve it. You already know the process of solving it. So what is the process to solve this differential equation? The process is that you first write the auxiliary equation. So the auxiliary equation is 2m square plus m minus 3 is equal to 0, which you will solve will give you 2m square plus 3m, right, minus 2m minus 3 is equal to 0. So this will, here you can take m common, you get 2m plus 3, and here you get minus 1 common, you get 2m plus 3 is equal to 0. So you get 2m plus 3 and m minus 1 is equal to 0. So the roots you are getting is minus 3 by 2 and 1. Since I have explained the whole process, that is why it has taken the time. Next question will be solved easily. So once we get this root, let me write the solution here in the top. The solution will be written as C1, or since they are using the constant capital A and capital B, let me use the term capital A and capital B. So I will be using capital A e to the power minus 3 by 2, and here you make the mistake. Don't make that mistake. Now since the independent variable here is z, I will not write x here, I will write z here, plus the constant b e to the power m2z, so that m2 term is 1, so z. Now some of you might be thinking, sir, this option is not present. So the idea is that since you have taken z is equal to log x, you have to reduce it further. So a e to the power minus 3 by 2 log x plus b e to the power log x. Yes or no? So a e to the power minus 3 by 2 log x will be what? I hope you understand the property of log and e. E to the power log x is equal to x, right? So here it is a, and using the property of log, it will be x to the power minus 3 by 2 and plus b x, right? So a x to the power 3 by minus 3 by 2 plus bx. So which option will be correct? The a option will be correct, because it will be like a x to the power 3 by 2 can be written as x to the power 3 by 2 and plus bx. So this is basically a by x root x plus bx. See, don't consider that, sir, here it is ax and here it is bx. Basically the way they have chosen the arbitrary constant here are in alternate order, so that is not a problem. So the correct option is A. It has taken a lot of time, but I hope the process is clear, so we can solve the same problem, next similar problem, directly and quickly. So now let us solve this problem, and this time I'll be doing it quickly. So the step 1 is that you replace x square y double dash by d minus 1y. So 2d minus 1y plus xy dash you replace by dy minus 6y is equal to 0. So this will reduce to what? This will reduce to 2d square minus 2d plus d minus 6y is equal to 0. Okay. So let us simplify it further. So this is 2d square minus d minus 6y is equal to 0. So originally this was an Euler-Cauchy form of the differential equation. Now this became a linear differential equation with constant coefficient. So what is the auxiliary equation? The auxiliary equation is 2m square minus m minus 6 is equal to 0. So let us factorize it. 2m square, and we need to write it minus 4m plus 3m minus 6 is equal to 0. So I can take 2m common, I get m minus 2. From this I can take 3 common, I get m minus 2 is equal to 0. So I get m minus 2 into 2m plus 3 is equal to 0. Continuing in this side, what we will get? So the factors are m minus 2 into 2m plus 3 is equal to 0. So m is equal to 2 and minus 3 by 2. So what will be the solution? Solution will be y is equal to a and e to the power 2z, right? Because I told you that you have considered that z is equal to log x, and plus b e to the power minus 3 by 2z. I have not written the details here because I want to save time, but I hope you understood this. So y is equal to a e to the power 2 log z, so x z, because for z I have to write log x, and b e to the power minus 3 by 2 log x. So this becomes y is equal to a e to the power 2 log x is x square plus b by x to the power minus 3 by 2 means 1 by x to the power 3 by 2 means x root x. So ax square plus b x root x. So which option will be correct? This option will be correct. See, the idea is that if you get here, you can directly write the solution also. So if the roots are like 2 and minus 3 by 2, then you can directly write the solution like ax square plus bx to the power minus 3 by 2. You don't have to write all these steps. I have just, so here also you can directly write, so I can get the answer ax square plus b by x root x. So this step can be avoided. We just got the root here and the solutions would be written like this. Okay. Next, this is another question which is slightly different, and here we have to use the method of variation of parameter. If the general solution of this differential equation is given like this, then what is the value of bx? Okay, so first of all, if you have to solve this, you have to find the particular integral using the method of variation of parameter. So see what they are saying. They are saying that the general solution is ax e to the power minus x and bx e to the power minus 2x. I am going to explain it, so it may take some time, but once you will understand, you can easily solve it. So you know what happens. First of all, you look at these two terms, and these two terms, that is y1 is equal to e to the power minus x and y2 is equal to e to the power minus 2x, are the two solutions, right, of its corresponding homogeneous linear differential equation. Get confused? Don't worry. Look at the process first. What I told, take this e to the power minus x as y1 and e to the power minus 2x as y2. And then there is something called Wronskian. So find the Wronskian. How do you find the Wronskian? You have seen in the previous videos. You take the first e to the power minus x, then you take e to the power minus 2x. Here you differentiate, you get minus e to the power minus x and minus 2 e to the power minus 2x. And you simplify. So cross multiply this. So minus 2 e to the power minus 2x and e to the power minus x. So e to the power minus 3x and plus e to the power minus 3x. So this will give you e to the power minus 3x with a minus sign. And now when we have to write ax or bx, this is how the ax is defined. Ax is defined as minus y2x by w dx. And how the bx is defined? The bx is defined as y1x by w dx. Now all those terms are clear now. This y1 is clear, y2 is clear, the w is clear, but there is a new term that is coming, that is x. So what is this x? This x is basically the right hand side of this differential equation. So 2e to the power x, and we also divide it by the coefficient of y double dash. Here the coefficient of y double dash is equal to 1, so it will be just 2e to the power x. So in the question they are asking us to find bx. So what is bx? Bx is y1x. So what is y1? Y1 is e to the power minus x into what is x? That is 2e to the power x, and by w, the Wronskian, that is minus e to the power minus 3x dx. Okay. Now how to solve it? So e to the power minus x and e to the power x. So it will become e to the power 0 means 1. And this 2 will be constant and this minus. So I can take minus 2 out. I hope you got. E to the power minus x, e to the power x, e to the power 0. So that is 1. And this minus out and this 2 out. So minus 2 out. And e to the power minus 3x, it will go in the numerator. So it will become e to the power 3x dx. So what is the answer? Answer is minus 2 e to the power 3x will give me e to the power 3x by 3 plus constant. Constant of integration. So I add c. So we got minus 2 by 3 e to the power 3x plus c. So which answer will be correct? Minus 2 by 3 e to the power 3x plus c2. Don't get confused with the term c2 here because it is also an arbitrary constant. So the correct option is B. I hope this question is clear to you because here this question requires some amount of patience to solve it. In case if you didn't get, please try to watch the video again, repeat the process again. Now the next question is that to find the particular integral for the differential equation by the method of undetermined coefficient, we choose the particular integral as, and we have solved similar problem earlier also, so we are going to solve it quickly. So as I have told you that when you have to find the trial solution or particular integral by the method of undetermined coefficient, you have to look at two things. You have to look at the complementary function and you have to look at the right hand side. So before I write the answer or trial solution, first decide what is the complementary function. So the differential equation is y double dash minus 2y dash minus 3y is equal to 0. So the auxiliary equation will be ms square minus 2m minus 3 is equal to 0. So let us factorize it. ms square minus 3m plus m minus 3 is equal to 0. So I can take m common, m minus 3 plus 1 common, m minus 3 is equal to 0. So I will get m minus 3 into m plus 1 is equal to 0. So I will get what? I will get m is equal to 3 and minus 1. Okay. So what is the complementary function? Let me write in this side. Complementary function is c1 e to the power, or since they are using c1 c2 here for the trial solution, let me use another constant, a e to the power 3x plus b e to the power minus x. Now I am going to look at the right hand side. So if I look at the right hand side, what should be the trial solution? The trial solution should be, because we have e to the power minus x here, it should have c1 e to the power minus x, and because we have e to the power x here, so it should have c2 e to the power x. Okay. Now compare these two. We don't have e to the power x term in the complementary function because it is e to the power 3x, it is e to the power minus x. So there is no problem with this term. But we do have e to the power minus x term here, right? And if you compare this and this, these two terms, you see that they are same thing. Only thing that they are different in the arbitrary constant, but basically the terms are same, e to the power minus x, e to the power minus x. So to make it independent, we have to multiply it by x. So the correct answer will be c1x e to the power minus x plus c2 e to the power x. So which option will be correct? C1x e to the power minus x plus c2 e to the power x. So this option will be correct. So this is how you should proceed with the problem. I think this is another method of undetermined coefficient related problem. So let us do it quickly. What is the complementary function? Before we write the complementary function, we should write the auxiliary equation. So what is the auxiliary equation? ms square minus 3m plus 2 is equal to 0. Look at this. So this will give you ms square minus 2m minus m plus 2 is equal to 0. So m can be taken common, m minus 2 minus 1 can be taken common, m minus 2 is equal to 0. So what we get? We get m minus 2 into m minus 1 is equal to 0. So therefore m is equal to 2 and 1, right? So what will be the complementary function? Complementary function will be c1, or since they are using c1 c2 for trial solution, so I am writing a e to the power 2x plus b e to the power x, right? Now if I look at the right hand side, what should be the trial solution? There are two terms. One is x square. So for x square, I am writing the general second degree polynomial. This is a polynomial of degree 2. So general second degree polynomial will be c0 x square plus c1x plus c2. All the terms x square, x and constant will be there. And for e to the power x, I have to write c3 e to the power x. Now you compare the complementary function and this. Certainly these three terms are not present in the complementary function, but e to the power x term is present. You see this b e to the power x and c3 e to the power x, means these are same term. So to make it independent, we have to multiply it by x. So now this is the correct trial solution. So which option will be true now? I think this option will be correct. Okay.